Hey guys, today we're going to talk about Sds Page. Sds Page stands for sodium dodecyl sulfate polyacrylamide gel electrophoresis. First things first, what is Sds Page used for? It's a method of separating proteins based on their size. Why is this important? Separating proteins by size allows you to isolate and identify them. You can then go on to study this protein further. To start, let's talk about proteins. Proteins are made up of building blocks called amino acids. There are many different amino acids, all with different properties. When you put these amino acids in different combinations, you end up with proteins that are massively varied in their size, structure, and charge densities. Now, we'll explain Sds Page step by step, or letter by letter. Remember, our goal in this experiment is to separate proteins purely based on their size. To do this, you have to keep the other characteristics, like structure and charge density, the same. This is achieved using SDS. SDS is an anionic detergent with two purposes. First, it denatures proteins, meaning that it gets rid of all these crazy 3D structures and reduces proteins to a single line of amino acids. Second, it coats the protein with negative charges, so that all proteins have a uniform mass to charge ratio, or charge density. Now it's time for the gel itself, Page. The PA in Page refers to polyacrylamide. Polyacrylamide is a gel matrix with small pores that your proteins can pass through. After treating your proteins with SDS, you load them on this gel matrix. The GE refers to gel electrophoresis. This means placing an anode and a cathode at opposite ends of the gel and allowing a current to pass through. Now this is where the physics comes into play. The anode and cathode create an electric field. The negatively charged proteins then experience a force due to this electric field. In accordance with the equation, force is equal to charge times electric field. This causes them to migrate towards the positive electrode. What allows for separation is primarily the difference in the size of the proteins. Larger, weightier proteins will experience a greater friction force that counteracts the force due to the electric field. Thus, they will not travel as far as smaller, lighter proteins that experience less resistance.